to do any of the packet. Today, I just want you to watch the video and take the notes. I want you to copy down the notes. We're talking about continuous functions today. This should be a review from Algebra 2 for you. Um, so we're going to start with, where is a function continuous? That's the question that we're trying to answer here. And we're going to be talking about this from looking at a graph. So by looking at the graph of a function, we should be able to tell if it's continuous or not continuous. Where is it continuous versus where is it not continuous? So the definition of a continuous function is, a function is said to be continuous if you can draw its graph and never have to lift up your pencil. So if you're drawing your graph and you don't have to lift up your pencil, it's continuous. But if you're drawing your graph and you're going through your graph without picking up your pencil, it's continuous. So a continuous function does not have breaks or gaps. So example one here, excuse me. Example one here. You notice you can draw this graph without picking up your pencil whatsoever. So you're drawing the graph without picking up your pencil, therefore it's continuous. And I just want to be technical with you for a minute. So we have our x and y. So for x, we have, as we go all the way to the left, x is approaching negative infinity, and x on the right, all the way to the right, is x approaches positive infinity. So as x is approaching negative infinity on the left, f of x, the graph on the left, is actually approaching negative infinity because it's going down, 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 down. But that's more for a different day, a different time. I just want to discuss while we have this opportunity. So on the right side, as x approaches positive infinity, the graph keeps going up, 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 up. So f of x actually approaches positive infinity on the right. So what we would say is this function f of x is continuous because I can draw this graph, I can trace this graph without picking up my pencil once. So if I can draw the graph the entire way without picking up my pencil. So we would say f of x, I'm going to type this. So we would say f of x is continuous. That's it. F of x is continuous. So in this graph, it is continuous. Now, if I wanted to write the interval, I would say it's continuous on the interval negative infinity to positive infinity, meaning it's continuous everywhere. Moving on to example 2. Don't pay attention to down here. I already did the lesson, and that's why that's there. But if you look at it, x goes to negative infinity and positive infinity on the right. So negative infinity on the left, positive infinity on the right. As this graph goes all the way to negative infinity, it goes down. But notice I can draw it. I don't have to pick up my pencil. But then I get to this thing right here, and I have to pick up my pencil. And what is that? Well, it's exactly what it looks like. We call that a hole. Hole. It's a hole. So right there is a hole. So I would have to pick up my pencil and then draw it again, right? So then I keep following down, and then I get to this point. Notice it drops down to here. So we call that a gap or a jump. So we can call it a gap or a jump. And if you notice, that point is x value is 2. Right there, x value here is negative 5. and right here we're saying x value is 6. So right here is something a little bit different. If you notice, so from 2 I jump down to here, and then my graph goes down, but then all of a sudden it's picked up at the top where it's going up to infinity. And so what we call that is a vertical asymptote. Vertical asymptote. If I can spell. So that is a vertical asymptote at x equals 6. So what we would say is this function is clearly not continuous because all throughout it I have to pick up my pencil. I can't just draw it smoothly. I have to pick up my pencil. So if you notice, f of x is not continuous. And I said it's not continuous at x equals -5, x equals 2, and x equals 6. So it's not continuous. Another way that we can say this, if we notice that this graph here, so we notice at example 3 here, it is not continuous, and you can look, we have a gap here or a jump. Again, it doesn't matter what you call it. So it's a gap or a jump. Call it whatever you want. Here we have a hole, and then we have, you could call it a jump too because there's a point. It's a point discontinuity. It's not a removable one because this is most likely a piecewise function. But what we can do is we can determine the if it's continuous on an interval. So remember, as x approaches -infinity to the left, so this interval would be from -infinity to, notice this is -5. So -5. So it is continuous from -infinity, but then I get to -5 and then I have a hole. So I have to jump over the hole, and it's not continuous at that point. But then we go from -5 all the way to 2 before I hit another hole. So then this is continuous from -5, and I'm going all the way to +2. And then again, I have a jump. So I jump up, and then I start my point 2 all the way to, notice it goes to +infinity, right? Make that a little bit better. +infinity, so it's continuous from 2 to +infinity. So we would write this as f of x is continuous on the interval. We would have -infinity to -5, from -5 to +2, and from 2 to +infinity. And if you notice, I have parentheses, or I have parentheses and not a bracket. We are going to talk about that later. But as for right now, the problems that we're doing, it's just parentheses. The -5 and the 2, they are called point discontinuities. So they're not included in my continuous interval. So again, today what I want you to do, watch this video, watch it a couple times if you need to, copy down the notes, and then tomorrow we're going to get into an assignment together. Gabby, I hope you have a good day. Take care of that little one. See ya.